6.3, P and Q are points on graphs G and F respectively such that PQ is parallel to the y-axis. If PQ lies between A and B, that's somewhere in between these points here, determine the values of x for which PQ will be a maximum. So if it is parallel to the y-axis, that automatically tells us that it is a vertical line. So PQ automatically is a vertical line, and we need to know the fact that our cost graph is on top. So if we take y top minus y bottom to actually get the length or an equation for PQ, we will take cos 2x minus into sine x plus 1. Right, so let's go ahead and work with that and try and actually come up with an equation for this for us to have an understanding. And when we are talking about maximum, kind of referring to the fact that it is essentially a trig graph but incorporated into a parabola or quadratic trig equation. So how are we going to do that? So when we see the word maximum, there is some sort of sad face parabola with a maximum value. So since we have cos 2x minus into sine x plus 1, we do not have any quadratic equation just yet, but we have a cos double angle identity which we can transform. And the goal is to transform this into the same. So since we have sine here, so we'll use our sine, the one with sine identity of cos 2x. So this would be 1 minus 2 sine squared minus sine x minus 1. And that helps us because it allows us to then, and this is plus, sorry, and this allows us to actually have the same trig function, because before we had cos and sine, now we have the same trig function, and this allows us to have a quadratic trig function, which is what they want us to find. So then our equation becomes minus 2 sine squared x minus sine x plus 2. And then that is our quadratic. And since we want the maximum, which is basically the turning point, our turning point equation is then, and what they want us to actually work out is the values of a between the x values for which there will be a maximum. So now since we do trig here, so this will be sine x now, since as a function of unit, and it's not x anymore, so that's equals to minus b over 2a, and b here, so here a is equals to minus 2, b is equals to minus 1, and c is equals to 2, and therefore we get sine x is equals to minus 1 over 4, and then we can have our two solutions where sine is negative, and therefore if we use our quadrant 3 and quadrant 4 formula where it's 180 plus 1 and 360 minus, we end up with where x is equals to 194.48 degrees. Or so if you take shift sine of 1 over 4, so here x, or let's call it reference angle, so kind of like a general solution, it's 1 over 4, and then you take 180 plus that shift sine 1 over 4. Let's actually write that in full. So here 180 plus 1 over 4, or x is equal to 360 minus shift sine. And thereafter you get your two solutions, which is 194.48 degrees or 345.52 degrees. And if we have a look, that is between our interval, or where they told us between A and B. So we have 194.48 and 345. So in between here, so 190 somewhere on this point here, and 345 somewhere on this point here.